Right, so question 1 is asking us about the ratio of the current in resistor X to the current in resistor Y. So the first thing that we can do is, let's call that I, right? And that's going through that resistor, okay, and it's got that potential difference drop across it, right? Okay, and those three things are linked by this formula. Now we're going to look at these other, and these are all identical resistors, right? So they're all worth R. So then we've got to think, what's the combined resistance of this bit of the resistor network just here, right? Like, what's the total resistance there? Now, when you put two resistors in parallel to each other, it's useful to remember that the total resistance is just halved, right? Okay, so the total resistance of this bit is going to be R over 2. If you want to work that out fully for yourself, you can use the formula 1 over RT equals 1 over R1 plus 1 over R2. And then if R1 and R2 are the same as each other, hopefully you can see that that's like this. So that's going to be 2 over R. Okay, and then if we cross multiply that out, hopefully you can see that, you don't need to cross multiply, you can take the inverse of both sides. There we go. Okay, sorry, that should say RT, shouldn't it, for the total resistor, my bad. Okay. Okay, so all of that to get you that, but it does come up quite a lot in IB questions that they put identical resistors in parallel with each other. If you've got 2 in parallel with each other, then the resistance is halved. If you've got 3 in parallel with each other, then you've got a third, the total resistance is a third. If you've got 4 in parallel with each other, the total resistance is a quarter, right? And then we're adding it to this resistance here, and that's in series, right? So the total resistance of this side of the circuit is going to be 2 over 2, so then that gets us 3 over 2 R, right? So if the resistor, right, if this number here has increased by a factor of 3 over 2, yeah, if we've got 150% of the resistance of the other side, hopefully you can see that that means that the current is going to be 2/3, and the reason why is because this thing over here, the voltage is going to be constant, right? All right. Okay, so where does that get us to now? That gets us to this point where we can say that the current flowing through this resistor here, the current flowing this way around the circuit is going to be 2/3 of I, and then of course the current's going to split again at this junction here. Okay, so you're going to get 1/3 of I going that way and 1/3 of I going that way, right? All right. So what's the current in X? We call that, now I'm trying to work out this ratio here, right? We call that current in X I, and the current in Y is going to be 1/3 of I. Okay, so hopefully you can see that the I's cancel out and the 3 comes up to the top, so the answer is D.